Good afternoon, everyone. Thanks for coming to this talk and giving me this opportunity. Okay. Okay, cool. So network scanning is if you don't know what it is, it's a process of attempting to find what ports are open in a server, or just scanning an IP range and looking for open ports within it. So network scanning is relatively bandwidth and processor intensive. Low power devices are unfortunately limited in both of these fields. And there are industry standard tools that do extremely good jobs at network scanning using standard hardware, such as like a laptop or a desktop. So the idea behind finding a low power device that is good at network scanning is using it for a rogue device, which would be used in, let's say, a penetration testing engagement, where you would leave a device in a network that you would otherwise not have connectivity into. So if you were attacking a corporation and you go to their office building, you find an open Ethernet port and you plug your rogue device in, and then you connect from outside. The goal would be to achieve maximum performance from these limited hardware platforms, and also determine what kind of performance loss are we dealing with when we're leaving a laptop behind and just plugging in a low-powered device. So the very first low-powered device I decided to explore was the Arduino Nano, which is pretty much a microcontroller, and I use an Ethernet shield, which is just another PCB you stick on top with a Ethernet port. And the bandwidth is sad, with 16 kilobits per second and a 16 megahertz processor. As a computer scientist, I didn't realize that processors could be that slow, but I dealt with it. And another challenge that I faced when implementing network scanning in the Arduino is the limited interface that you have with the device itself. The libraries available are slow and difficult to use. But another very important part of a network scanner is the fact that when you open a connection to a socket and you wait for a connection back, you don't want that connection to be blocking the rest of the process. So you want to use multi-threading or multitasking whenever possible. And an Arduino is not very good for that. So the Raspberry Pi Zero is actually a very powerful platform for the amount of power that it uses. 2.4 gigahertz of bandwidth, which is more than capable of network scanning at decent pace, and 1 gigahertz processor, which made multi-threading or multitasking a lot easier. And the implementation was a lot easier because it actually has its own operating system. I ran Ubuntu on the Raspberry Pi, and that gave me access to Python. So I decided to implement my own network scanner instead of using something like Nmap or MassScan on the Linux box. And I got some decent results from that. So we'll see in the next slide. I have four different tools that I used. The first is Nmap on standard hardware, MassScan on standard hardware, and then NetScan is my Python implementation. As you can see, it's not optimized. And then I used Nmap on the Raspberry Pi itself. And then I tested that against 4 different networks of varying sizes. The first 3 networks were 256 hosts large, and the 4th network was 4,000 and something, 4,000 hosts large. So that's why the last results are so much larger. The scans took so much longer. MassScan is incredible at scanning large networks really, really quickly. Nmap is not as optimized for that, but it is better for general purpose, smaller, more targeted scans. And I found that Nmap on the Raspberry Pi was it was decent. You didn't lose that much performance between the standard hardware and the Raspberry Pi. I used it in its default configuration. I didn't attempt to use any optimization options that it has available. And my NetScan Python, I called it NetScan, but the Python implementation was I thought that it would be relatively fast because I took away all of the fluff and the extra stuff that Nmap provides, but unfortunately, Python could not keep up. So, in conclusion, I found out that Arduinos are not viable platforms for network scanning due to their limited processing and bandwidth. And then usually because I leave the possibility open to some amazing people out there that might be able to write some more optimized code, but I definitely would not be able to make anything better than Nmap or MassScan. Yeah, so I appreciate your time. Thank you. I hope it was a short conversation, but sweet, hopefully. So thank you for your time.